Welcome pre-cal students to the homework help video, page 879, numbers 1 through 9 all, and number 17. Go ahead and get your books open and let's get started. Let's take a look at number 1. The directions for 1 through 4 state list the first 5 statements in sequence that can be obtained from each of the following. Determine whether each of the statements is true or false. Okay, so we're going to put a 1 in, then a 2, then a 3, then a 4, then a 5, and we're going to see if we get out true statements. So 1 times 1 is 1, 1 cubed is 1, 1 is less than 1, and that's false. Let's put a 2 in, 2 squared is 4, 2 to the third power is 8, 4 is less than 8, that's true. Let's put in a 3, 3 squared is 9, 3 to the third power is 27. That's true. Let's put a 4 in. 4 squared is 16, and 4 to the third power is 64, and 16 is less than 64. That's true. Then we'll put a 5 in. 5 squared is 25, and 5 to the third power is 125. And this is definitely true here. 25 is less than 125. So that's all they wanted you to do. They wanted you to put in the numbers for the first 5 terms and see if all the statements are true. We can see right away that this is false. 1 is not less than 1, so this is not a true statement. Now, if they had done one thing differently to this expression and put an equal sign here, and then all of these would have equal signs, then this would be an accurate expression, okay, for all natural numbers starting at 1 and going higher, okay? All right, let's continue on and take a look at number 2. Number 2 says n squared minus n plus 41 is prime. Find a value for n for which the statement is false. So basically what they're saying is this. You can put numbers in 1, 2, 3, 4, 5, whatever, and you should get out a prime number every single time. Now, of course, we could spend all day putting numbers in. I'm not going to do that to you on a test or a quiz. I wouldn't do that to you. But what they're trying to show you guys, listen to me, what they're trying to show you is an expression can look totally true, but it only takes one counterexample to prove it wrong. For example, let's put a 1 in. 1 times 1 is 1, minus 1 is 0, plus 41. So when you put a 1 in, you get out a 41. Let's put a 2 in. 4 minus 2 is 2, plus 3 is 43. Let's put a 3 in for n. 3 times 3 is 9, minus 3 is 6, plus 41 is 47. Let's put a 4 in. 4 times 4 is 16, 16 minus 4 is 12, 41 plus 12 is 53. I'm getting out all prime numbers, guys. Put a 5 in for n. 5 squared is 25, 25 minus 5 is 20, plus 41 is 61. All of these are prime. So we could go on, and it looks really, really, really good. But guess what? I don't have a calculator in front of me, and I know I should. I apologize. I just don't. But if you put 41 in for n minus 41 plus 41, you will not get out a prime number. Now again, I'm sorry, I don't have a calculator in front of me. Let me see if I can grab one real quick. But while I'm doing that, if you put 41 in for n, I'm using my cell phone here. 41 squared is 1,681 minus 41 plus 41. These would obviously cancel, so you're left with 1,681. Now, I'm not sure what number goes into that. I have to do a little research, but there's a number that goes into it that is not a prime number, okay? And I'm trying to think of what that would be real quick. 2, 12, 48, 6, 7, I'm not sure what it would be, but when you put 41 in for n, you do not get out a prime number. So think how you would have kept testing this expression. You would have put a 6 in, a 7, you would have got to about probably 10 or 11 and said, I'm done with this. It's obvious this thing always works, and it's not. Here's one expression where it didn't work. Okay, and that's why we're using mathematical induction today to prove or disprove these expressions, because just putting numbers in like this right here doesn't always prove something. Okay, number 3, a polygon of n sides has this many diagonals. Now real quick here, we're not going to start with 1 and 2 because you can't have a polygon with one side or two sides. A polygon has to have at least 3. So here we go. There's a triangle, that's 3 sides. There's a rectangle, that's 4 sides. And here's a pentagon, that's 5 sides. Okay? Now, let's put this is 3 sides, let's put a 3 in for n. 3 minus, I'm not going to do all that work. 3 minus 3 is 0, times 3 is 0, over 2 is 0. So when you put a 3 in, you have 0 diagonals. And that's right. A diagonal is when you can connect one vertex to another vertex as long as the vertex is not right beside it. So in a rectangle over here we have a diagonal, and we have another diagonal, and you can't draw anymore. That's all you can draw. Here you can't draw a diagonal. If you went from here to here, you're just retracing a side. If you went from here to here, you're just retracing a side. If you went from this vertex to this vertex, you're just tracing a side. So a triangle has 0 diagonals. Okay, let's put a 4 in right here, and you would get 4 minus 3 is 1, times 4 divided by 2 is 2. So if you put a 4 in, you got a 2. So we should get 2 diagonals here. So far this is true, so far this is true, and this one's going to be true also, by the way. Let's go ahead and put a 5 in. There's 5 sides. You would get 5 out. 5 minus 3 is 2, times 5 is 10, divided by 2 is 5. So we should get 5 diagonals. Start here and draw all the diagonals you can. Now start here and draw all the diagonals you can. And then when you come here, we have that one drawn. We can draw this diagonal. And now there's no more that we can draw. Okay, so we have, let's highlight them in red. We have 1, 2, 3, 4, 5. So that statement is true also. So that's all they asked us to do in the directions, is just list the first 5 statements and see if they're true. Okay, so far so good on that one. Okay, number 4. This is also going to work. This is a geometry formula here. The sum of the interior angles of a polygon is represented by this. So again, we really can't have a one-sided or a two-sided polygon. Sorry about that. We can have a 3-sided polygon, 4-sided polygon, or a 5-sided, and we're stopping at 5 because the direction said to go up to 5. So we're going to put a 3 in. 3 minus 2 is 1. 1 times 180 is 180, and that's true. That's true. We know that in a triangle, the sum of the 3 angles equal 180. Okay, let's put a 4 in now. 4 minus 2 is 2. 2 times 180 is 360, and that's true. That's true, guys. Anytime you have a 4-sided polygon, the sum of the interior angles is 360. If you had a rectangle, right angle, right angle, right angle, right angle, 360. If you didn't have a rectangle, if you had a really weird shape like this, all of those interior angles would still add up to 360, trust me. And the same thing down here, it works just fine. Put a 5 in. 5 minus 2 is 3. 3 times 180 is 540 degrees. If you have a 5-sided polygon, all of these 5 angles right here, when you add them up, will add up to 540 every time. So they just wanted you to put numbers in and get numbers out. That's it. Nothing difficult. Now let's get into the harder math, okay? So here we go. Let's take a look at number 5. All right, they want us to prove this expression. Now, first of all, I'm going to quickly check the nth term. I'm going to put a 1 in, I get out of 2. Put a 2 in, I get out of 4. Put a 3 in, I get out of 6. Now I'm going to check my sum formula. I'm going to put a 1 in and I get out 2, and that's right. I'm going to put a 2 in and I get out 6. Well, 2 plus 4 is 6. I'm going to put a 3 in and I get 12, and that's right. 2 plus 4 plus 6 is 12. So I just kind of checked everything. Everything looks good. Let's go ahead and put k in everywhere there's an n. So 2k equals k plus 1. There we go. That represents my first term. Now let's go ahead and put k plus 1 for the second term. So here's an n right here. I'm going to put k plus 1. So 2 parentheses k plus 1 equals, and here's an n right here, so I'm going to put k plus 1, and then inside this parentheses I'll have a smaller parentheses, and for n right here I'll put k plus 1 plus 1. Okay, for n right here, I put k plus 1 and then brought down my plus 1. Now the only problem is, sorry about that, the only problem is remember, when I put k plus 1 in, that means I'm adding up two terms. So I've got to bring down my second term right here, my 2k, or my first term, my 2k, and there. So I have my first term plus my second term equals my sum expression over here. Okay, and now we're ready to take this expression, substitute it in, and solve. So 2k equals this right here, so I'm going to substitute this for 2k. So my 2k is officially gone, and halfway officially gone. There we go. And now we're going to go ahead and put right here k plus 1. Now let's simplify these two sides and see if we get out a true expression. Take your k and distribute it through. K times k is k squared. K times 1 is k. And then take your positive 2, distribute it through. 2 times k is 2k. And 2 times 1 is 2. Now I'm going to go ahead and quickly simplify this side. I would have k squared plus 3k plus 2. Now let's come over here. Let's simplify inside the parentheses first. So I bring down my first parentheses. And then in my second parentheses I would have k plus 1 plus 1. So that's really going to be k plus 2. And now trust me, if you do your FOIL method, k times 2, 1 times k, 1 times 2, you will get this right here. K squared plus 3k plus 2. Alright, so booyah, it checks, we're good, there we go. So we just proved that these are true expressions. Let me get a drink here and we'll continue on. Number 6. Alright, let's quickly just check everything, make sure it lines up. Here's my nth term right here. Put a 1 in, I get out of 4. Put a 2 in, I get out of 8. Put a 3 in, I get a 12. So that checks. Alright, put a 1 in, I would get 2 times 2 is 4. Put a 2 in, I would get 4 times 5 is or 4 times 3 is 12, and that's right. 4 plus 8 is 12. Put a 3 in, I would get a 6 times 4 is 24, and that's right. 4 plus 8 plus 12 is 24, so that expression checks. So this is my nth term, and this is my expression for the sum of any given terms. So I'm going to go ahead and put a k in. So 4k equals 2k, k plus 1. There's my first term. And now for my second term, don't forget, I'm going to put 4, and then for my n, I'm going to put k plus 1, and then 2, and then parentheses for my n right here, and I'm going to put k plus 1, and then for my n right here, I'm going to put k plus 1, and then bring down your plus 1 from right here. Okay, and then close the parentheses. Now the only problem is when you put k plus 1, you're basically saying you're adding two terms together. Okay, so this is a representation of my first term, so I'm going to bring down 4k. So there's my first term plus my second term equals this sum over here, hopefully, theoretically. So let's see if it does. I'm now going to make a substitution. I'm going to put this in for this right here. Okay, and then we'll be good to go. So here we go. Now you'll probably have to pause the video because I've already written everything out, so we're going to go pretty fast, but you pause the video and copy things down. You'll probably be doing that quite a bit, which is fine. Okay, we're going to go ahead and make our substitution here. and we're going to substitute this in for this like I said a second ago. If you do that correctly, you'll have this right here. Notice I substituted this out and put this in place of it. I'm not going to worry about the right side right now. I can simplify that later. We're just going to work with the left side. So now let's do some simplifying. You can take your 2k, multiply it through, and take your 4 and multiply it through. If you do that correctly, you will come up with this right here. Okay, 2k times k, 2k times 1, 4 times k, 4 times 1. Now, if we combine our like terms, you will come up with this right here. Notice we have two like terms here we can put together, 2k plus 4k, and that would give you 6k. These two terms together give you this. Now, we cannot simplify this anymore, so let's direct our attention to this side over here. I'm going to start simplifying inside my parentheses. Over here I have k plus 1 plus 1. So I really can put k plus 2. So now I bring down my 2, bring down my k plus 1, and this parentheses here became k plus 2. Now, next what I'm going to do is I'm going to bring down my 2, and I'm going to multiply these two groups together. K times k, k times 2, k times 1 times k, 1 times 2. And I'll get out a really big expression here. Okay? And if I do that correctly, I will get this right here. K squared plus 3k plus 2. And now simply if you take your 2 and distribute your 2 through the parentheses, you will get this right here. And notice both sides are equal. So we did it. So very good. Moving on to number 7. Let me get a drink here. Okay, taking a look now at number 7. First of all, let's quickly check our terms here. Here's your nth term right here. So, put a 1 in, you get out a 1. Put a 2 in, you get out a 5. Put a 3 in, you get out a 9. So far so good. This expression checks. Now, let's come over here, put a 1 in, and I would get 1 times 1 is 1, which is the sum of the first term. Let's put a 2 in, I would get 6, and 1 plus 5 is 6. Now, I'm going to put a 3 in, and you would get 5, 15, and 1 plus 5 plus 9 is 15. So this expression checks. This is my nth term, and this is an expression for the sum of any given terms. So let's go ahead and put k in for n. I would have 4k minus 3 equals, and then for this n I'm going to put a k, and then 2k minus 1. Okay? Now, that's my representation of putting in a k for my first term. Now let's put in k plus 1. So here's my 4, then an n. So I'm going to put 4 parentheses, k plus 1, and then after my n I have minus 3. So minus 3 equals. Then here's an n right here. I'm going to put parentheses because it's two terms, k plus 1, and then I have another parentheses, and I'm going to put 2 and then an n, so a little parentheses k plus 1, and then bring down my negative 1. And now we're pretty much all set, except don't forget, this is an expression here of adding up two terms, and so you have to have your first term plus your second term. So I'm going to bring down my 4k minus 3 and put a plus sign. So this right here is my first term, this right here is my second term, and when you add them together, you get this expression over here. Okay? So here we go. Let's go ahead and get started. First of all, I'm going to make my usual substitution. 4k minus 3 equals this right here. So I'm going to put that in place of this over here. All right? So let's quickly get rid of this. And we're going to slide this down. Almost slide it down. And now let's go ahead and start simplifying. Let's start on the left side first. Multiply your k through, and you would have 2k squared minus k. Then multiply a positive 4 through. 4 times k is 4k, and 4 times 1 is 4. And then bring down your negative 3. Now let's combine like terms, and we would finally end up with 4k squared plus 3k plus 1. I combine these two terms to get 3k. I combine these two terms to get 1. And now let's simplify over here. Obviously my first parentheses can be left alone, but my second parentheses is a little different. First of all, I can multiply my 2 through this little parentheses. So 2 times k is 2k, and 2 times 1 is 2, and then bring down your negative 1. Okay? And now if you combine like terms, k plus 1 times 2k plus 1. And I'm going to save time. I'm not going to work all this out, but please trust me. If you took k and distributed it, and then your 1 and you distributed it, you would get 2k squared plus 3k plus 1, which would equal this side right over here. Okay, so moving on, we're doing great. We have 8, 9, and 17, and we're finally finished. Okay, number 8. Let's quickly check our nth term. Put a 1 in, you get out of 3. Put a 2 in, you get out of 6. Put a 3 in, you get out of 9. So this checks. Now let's check our sum expression. Put a 1 in, and you get 2. 6 divided by 2 is 3. That's good. Put a 2 in, and you get 3 times 6 is 18 divided by 2 is 9, and 3 plus 6 is 9. Now we'll put a 3 in. That would be 4 times 9 is 36, divided by 2 is 18, and that's right, 3 plus 6 plus 9 is 18. So this checks. So next, everywhere there's an n, we're going to put a k. So 3k equals, and then up here we'd have 3k, k plus 1, all over 2. So everywhere there was an n, I put a k. Now we're going to put k plus 1. So here's an n, so 3 parentheses k plus 1 equals, and then up here we have 3 and then an n, so parentheses k plus 1, and then inside the parentheses we have an n right here, so I'll put a smaller parentheses k plus 1 and then plus 1, and then close your parentheses, and then all over 2. And so now we're going to take this expression here and we're going to do some work with it, okay? Oh, by the way, I forgot. Remember, this expression here is the sum of two terms, and this right here, this expression is your second term, so we got to bring 3k down. And this expression here is my first term. Almost forgot to do that. So we're adding these two terms together, all right? There we go. Okay, so let's make our usual substitution, and then let's see if we can't solve this, okay, or simplify it. So for the 3k, I'm going to drop that out very quickly, and I'm going to bring this in place of it right here. And I think it'd be wise to get some more room. I just have that feeling. So I'm going to open a new page here, and let's slide this up top. And now let's go ahead and get started. Let's see how we do. Okay, so we have a new page here, and what we're going to do now is we're going to simplify the left side, the right side, and see if we can't get a true statement in the end. So the first thing I'm going to do is I'm going to distribute my 3k through this parentheses, and I'm also going to put this over 1. Now the reason I'm going to put this over a 1 is I have two fractions here. I have one fraction over here. More than likely I'm going to have to get a common denominator and put these two fractions together. So there we go. I took my 3k, distributed it through, and then put this over 1. Now what I'm going to do next is this. Now I'm going to get a common denominator. Now a common denominator for 2 and 1 is 2. So I'm going to multiply the bottom of this fraction here by 2, but I must also multiply the top of this fraction by 2. And the reason I'm doing that is now my denominator will be 2. So I'm going to multiply the top of this fraction by 2, the bottom of the fraction by 2, multiply this 2 through. 2 times 1 is 2, 2 times 3k, 2 times 3, and you'll get this here. You will get 6k plus 6 all over 2. Now I have a common denominator. Now students, you know by now when you have a common denominator, you can put a real big fraction bar, put your common denominator right here, and you can put your two numerators together. You can add them. So if you do that correctly, you'll come up with this right here. 3k squared plus 3k plus 6k plus 6 is this right here. Your 3k and your 6k gave you a 9k right here. Now let's work with the right side. I'm going to bring down my 3k plus 1, and I'm going to take this parentheses right here, and I'm going to realize that k plus 1 is k plus 2. So I bring down my 3, bring down my k plus 1, and I have k plus 2. Now I'm going to take this parentheses here and this parentheses here and multiply them together. K times k, k times 2, 1 times k, 1 times 2. If you do that correctly, you will get k squared plus 3k plus 2. Now take your 3 that's on the outside and distribute it through, and you will come up with 3k squared plus 9k plus 6 over 2. Checks. Totally fine. All right, and then almost done. This one, then one more, and we'll finally be finished. Okay, let's check our nth term right here. Put a 1 in, you get out of 2. Put a 2 in, you get out of 4. Put a 3 in, you get out of 8. So far, so good. Now let's check our sum expression. Put a 1 in, and you get out 2. Put a 2 in, that's 3 times 2 is 6, and 2 plus 4 is 6. Put a 3 in, you get 14, and 2 plus 4 plus 8 is 14. So this checks, and this checks. So let's go ahead and start simplifying this, algebraically improving it. Put a k in for n, so 2 to the k. And then over here, put a k in for n, so 2, parentheses, 2 to the k power, and then minus 1. Let me get a drink here real quick. All right, moving on. And now let's put our k plus 1 in. So now I would say, okay, 2k plus 1 equals 2, and then 2k plus 1 minus 1. Now the only thing is, remember, this expression right here is the sum of your first two terms, and so I've got to bring this down over here and put 2 to the k plus. So this is like my first term, this is like my second term. Add them together, you get this expression over here. So with that in mind, let's go ahead and do some simplifying now. Obviously, I think what I would do first, I'm trying to think the best way to do this. Well, the first thing we definitely need to do is to make our substitution. We know that. And so for 2k right here, I'm going to substitute that out and put this expression right here. All right, let's go ahead and do that, and we'll have this right here. Now, exponents can be really, really tricky, so please pay attention and watch, okay? The next thing I want to do is multiply my 2 through this parentheses, okay? Now, this 2 is really 2 to the 1 power, so when I multiply 2 to the 1 times 2 to the k, remember when you're multiplying like bases, you write the base once, and you add the exponents, so 1 plus k. Now 1 plus k, students, as you understand, is the same thing as k plus 1. So 2 to the 1 times 2 to the k is 2 to the k plus 1. And then 2 times negative 1 is negative 2. So if you do all of that correctly, you will end up with this right here. 2 to the k plus 1 minus 2. And then I just simply brought this expression down. Now, look what we can do next. See if this makes sense. I have a 2 to the k plus 1, and I have a 2 to the k plus 1. I'm basically adding those together, okay? In other words, if I could move them so that they were side by side, I would just simply take this right here, bring it over right here, put a plus sign, and now I have 2 to the k plus 1 plus 2 to the k plus 1. Well, look, guys, let me ask you a question. If I have 2, I don't like to use number 2, in this example, if I had 5 plus 5, isn't that the same thing as just saying 2 times 5? Sure, 5 plus 5 is 2 times 5. If I had 11 plus 11, isn't that the same thing as just 2 times 11? Sure it is. So if I have this plus this, would that not be the exact same thing as just saying 2 times 2 to the k plus 1? Sure it is. And then bring down your negative 2? Sure, it's the exact same thing. Do you see it? 11 plus 11 is 2 times 11. 5 plus 5 is 2 times 5. This plus this is 2 times this. The exact same thing. So you would have this right here. If you add these two together, you'll get this right here, and then minus 2. All right. Now, I'm going to quit simplifying this. I guess you could multiply the 2 through and all of that, but I'm going to hold off. I'm going to come over here and work on this side now. Now, if I take this 2 to the 1 right here and I multiply it through like this, 2 to the 1 times 2 to the k plus 1. Yes, we could add our exponents, but since I have this written down here like this, see this right here? Since I have that, I'm just going to go ahead and say 2 to the 1 times this would be 2 to the 1 times this. So this times this gives me this right here. It's not too bad. And then 2 to the 1 times -1 would be -2. So it would look like this right here. There we go. And does not this side here match this side here? Now, if you didn't like that, I would have kept going. Fine, you can keep going. Here we go. 2 to the 1. 2 to the 1 times 2 to the k plus 1 would be, well, you're multiplying like basis, so write your base once, then add the exponents. And 1 plus k plus 1 is k plus 2 minus 2. Then do the same thing over here. 2 to the 1 times 2 to the k plus 1, multiplying like basis, so write your 2. Add your exponents. 1 plus k plus 1 is k plus 2 minus 2. That's fine. I don't care as long as the two sides match. Okay? Last problem and we're finally done. Number 17. Let's see if we can't figure this out. And you can see now why I didn't give you the whole assignments with the inequalities and with the longer expressions. Some just are really long and there's no need for that. Okay? All right, here we go. Let's put a 1 in for our nth term. You get a 1. Put a 2 in, you get a 2. Put a 3 in, you get a 3. So this checks. Put a 1 in here and you get 1. That's good. Put a 2 in and you get 6 by 2 is 3. 1 plus 2 is 3. Put a 3 in and you get 12, 6. 1 plus 2 plus 3 is 6. So this checks. Okay? Now let's go ahead and put k in for n. So k equals k plus 1 all over 2. And now we're going to put k plus 1 in everywhere there's an n. So here's an n, and I'm going to put k plus 1 equals, here's an n right here, so I'm going to put parentheses because it's two terms, k plus 1, and then a parentheses, and then for n I'll put a smaller parentheses, k plus 1, and then all over 2. All right? And now, that looks pretty good, except remember, this expression right here is the sum of two terms. So I must bring down my k and put a plus sign. And this is my first term, and this is my second term. And when you add them together, you should get this. Now, step 1, of course, is to make your substitution. So for k right here, I'm going to get rid of this k. And we're going to put this in place of the k. There we go. Not too sloppy. And now let's go ahead and simplify this left side. K times k times 1. That would be k squared plus k all over 2. And then right here, I'm trying to think how the best way to do this. I'm going to go ahead and put k plus 1 all over 1. So k plus 1 all over 1. Now the reason I did that is obviously I'm going to have one fraction over here, so I'm going to have to combine these two. Now in order to combine these two fractions to get one fraction over here so it matches this side, I'm going to have to get a common denominator. A common denominator for 2 and 1 is 2. So I'm going to multiply the bottom of this fraction by 2, but I must also multiply the top of this fraction by 2, and if I do that correctly, I will come up with k squared plus k all over 2 plus 2 times k is 2k, 2 times 1 is 2, all over 2. And now I'm ready to add these two fractions. So I'm going to put everything over 2, and here we go. I would have k squared, there's no k squared over here, plus k plus 2k, so I would put a 3k, and then plus 2. So there we go. I combine these two fractions. Now, over here, I've got to simplify this parentheses first. So I would bring down my k plus 1. And then over here, k plus 1 is k plus 2, all over 2. And then trust me, if you take k times k, k times 2, 1 times k, 1 times 2, you will end up with k squared plus 3k plus 2 all over 2. Check. So there we go. That's the homework help video. I hope this has been a help to you. Call me or email me if you have any questions, and hope this has been a help to you.